problem 51. 51 from this section says we know that the tangent of theta is -1. So I'll punch that up for you here. And I'm going to take out the unit circle and take a look. Because you're right. When we look at our unit circle, we know that the coordinates of the points are sines and cosines, right? Now, what's our definition of tangent then? Tangent is y over x or sine over cosine, right? So basically, I'm trying to find where y over x is going to be -1. Okay? So if I throw that unit circle back up here, I want to point out that you can actually figure out which quadrant you have to be in first, right? See, I'm not going to be in quadrant 1. How do I know that? Everything in quadrant 1 is both positive, and we said tangent of theta has to be negative, right? -1. So I'm not going to be here. And as I look in quadrant 2, I don't know. I think they tried to make it easy enough, you know, like, hey, there's a point where y and x are the same, so it's going to be -1. You see that? Now, what do you do if you don't know that? And by the way, so what would my answer be for theta here, or one of the answers? 3 pi over 4, right? But that's not the only answer. There's other answers. What other quadrant do you guys think I should look in? Quadrant 4, because again, you're going to get points where in quadrant 4, the x-coordinate or cosine is going to be positive and the y-coordinate is going to be negative. And so I guess where I want to look for that one would be right here, right, at the 45-degree angle down, okay? So you could call this -pi over 4, or if you're going all the way around, maybe you call it 7 pi over 4, something like that, okay? And so the coordinate of that one also is positive radical 2 over 2, negative radical 2 over 2. So there really are lots of answers, right, for this problem. So what do I say about theta? Well, I say theta could be 3 pi over 4. I found that angle. Theta could be 7 pi over 4, or theta could be -pi over 4. I mean, there's lots of answers. If I want to list all of them, by the way, what's the difference between this angle and that angle? Well, one's positive, one negative. It depends which way you're going around the circle, right? And we know that every time you go around the circle completely, an extra rotation is how far? 2 pi radians, right? And so what I could do is I could, for example, if I want to list all the solutions, I could pick the one from quadrant 2 and pick either of these from quadrant 4. And then what I'll do is I'll say, well, my answers are 3 pi over 4 plus, well, I need to take 2 pi and multiply by any integer you want, where k is an integer. So if k is 0, then I just have 3 pi over 4. But if k is 1, that's like an extra rotation. So another answer would be, say, -pi over 4 plus 2 pi k. So for example, if k is 1, see, notice, if k equals 1, you get -pi over 4 plus 2 pi, and that's -pi over 4 plus 8 pi over 4. That's 7 pi over 4. So you're going to get the other version of that angle. So I think the way I would list the answer to this question would be something like this. Okay? What thetas work? Well, theta could be this, or theta could be this, and again, k could be any integer. There's really infinitely many answers because you could rotate around as many times as you want and end up at the same place. Does that make sense? Good. You know, this leads into something we're going to be doing today. We're going to start graphing the trig functions. The trig functions come from the circle, but we're going to start graphing them. And one of the things we're going to find out about the trig functions, here's the word that we're going to learn: periodic. What happens is the trig functions repeat over and over again because your input is an angle, and your angle, you just keep going around the circle. So we're going to see that today. Now, Nick asked about 96. Let's take a look at that because a number of you may have trouble with the identities, okay? So when you have an identity, and we're supposed to verify it, verify the identity, my advice is take the more complicated expression and try to make it look like the simpler expression. All right? Let's see if we can do that. So 96 says, and some of these are easier than others. This one, well, we'll see. Cotangent of theta divided by cosecant squared of theta minus 1 equals tangent of theta. Wow. Okay. I guess if it were me, which side do you think I'm going to start working on, the left or the right?
Left.
Yeah, that's more complicated. The left's more complicated, so we're going to work on that. Okay? I'm going to try and get it to look like tangent of theta. By the way, tangent of theta, what's another way of writing that? Just maybe in your mind you're thinking already. What's the definition of tangent we just said? Sine over cosine is one way to think of it. So if I ended up getting this to be sine over cosine, I'd be happy. All right? Now, I'm going to work on this. And what I'm going to say it equals is a fraction. And let me kind of write the parts separately. Okay? First of all, cotangent of theta. What does that equal? Cosine over sine. So let's write cosine of theta over sine theta. That's my numerator. Now the denominator, well, you know what I think about the denominator? And here's what I think. I look at that expression, and I see something squared, and I see a minus 1. And I start thinking about the Pythagorean identities that we learned earlier. So let me do a little reminder on the side that we studied the Pythagorean identities. And I don't know if this has bothered you yet, but you might start saying to yourself, how the heck am I going to remember all these things? Okay? Well, I'm going to tell you that there's one that I bet I'm going to write down. You say, I can remember that one. You ready? What's this equal?
1.
I knew you'd remember. Sine squared plus, because really it's x squared plus y squared is 1. That's the Pythagorean theorem. Okay? And so I'm going to start with that, and then we'll see what we're able to do. Anyways, I have this one down here. Oh yeah, I'm working on the Pythagorean identity. Now, cosecant, what's that? Isn't that 1 over sine? So I want to get 1 over sine involved. So what I would do here is take this Pythagorean identity and divide everything by sine squared. So what does it say now? Well, now it says 1 plus cotangent squared theta equals, oh, now I see what you're doing. Is this right, Molly? Because you're saying, look what happens, Paul. The cotangent's going to show up. Because look, I got this far. And so now, if I subtract 1, okay, I can learn something. I can learn, if I subtract 1 from both sides, I learn that cosecant squared theta minus 1 is actually equal to what? Do you guys see it? I subtract 1 from both sides of the green equation. So what's cosecant squared minus 1 have to equal? Cotangent squared. Are you with me? You guys are real quiet. Raise your hand if you're with me on the right-hand side, what I just did. Okay. If you're with me there, I'm in good shape. So now what I do is where it used to say cosecant squared minus 1, what can I write? Cotangent squared theta. Well, you know, I kind of agree with Molly. Why did I do this? This thing said cotangent theta. Right? And what's kind of nice about that is now you can write what's cotangent theta over cotangent squared theta. Can't we cancel? So this is the same as 1 over cotangent theta. And what's the reciprocal of the cotangent? Tangent. Done. Okay? But I didn't know that at first. Right? But once you get here, you're like, oh. So that's a proof that really this ugly fraction on the left-hand side is just another way of writing tangent. Okay. Last question that Lindsay asked, and this is worth talking about for sure. You guys worked on problem 78. Here it is. And I want to highlight, when you guys get to problems like this, you could easily get overwhelmed. And when I read a problem with this many words, I'm going to tell you, I don't read this word problem like I read a novel. You're not going to see me on page 750. I don't read it like that. No way. I go right to the question that's being asked. I want to figure out what's it trying to ask me. Boom. Show that if the horizontal is above and parallel to level ground, then the angle of depression from observer to object, that's this angle, and the angle of inclination from object to observer will be congruent because they are alternate interior angles. By the way, that alternate interior angles thing, that's from geometry class. I don't know if you remember that, but I'll give you the lowdown here. You know, their picture in the book looks something like this. There's an observer. Let me put it up where you can see it. There's an observer, and they said this angle is theta. And here's the object. And this is horizontal. And what part A asks is, hey guys, if we have level ground that the object is on, that you're observing, and they're talking about angle of inclination. See, this guy up here, this theta, that's called angle of depression. But there's another angle, it says, from the object to the observer. This is called the angle of inclination. And there was a theorem in geometry class that you may have had at some point that said if those are parallel lines, this also has to be theta. That's what part A is all about. Okay? I remember seeing that at some point in your life. If not, you learn something new. Okay? Now part B. From a fire tower 200 feet above level ground, a ranger spots a fire off in the distance. The angle of depression is 2.5 degrees. How far away from the base of the tower is the fire? So I guess for part B, you know, we could draw a similar picture. Here's my tower. Here's horizontal. Off in the distance, there's a fire on the ground. There's my 2.5 degree angle. Okay? And what it says is, how far away from the base of the tower is the fire. And this is why they build these fire towers, right? Because they see a fire in a forest, they want to get to it right now. They got to know how far away it is. So we know the tower is 200 feet. Now, this is not to scale, right? 2.5 degrees is much smaller of an angle than this. But I'm drawing it this way so it'll fit on the paper. And I guess what I know is whatever this angle of depression is, has to be the same as this angle of elevation. And what I'm trying to figure out is x. What is the distance from the fire to the tower? And so I could say something like this. I could say, oh, by the way, which trig function do you think I want to use for this problem? Yeah, this is a right angle here. That's tangent. We're going to say tangent of 2.5 degrees is equal to, I guess it would be 200 over x. And here, x is also going to be measured in feet. So if I multiply both sides by x, x times the tangent of 2.5 degrees is equal to 200. And now I need the calculator. And I'll make sure I'm in degree mode for this to work. So let's see. My mode, yeah, I'm in degree mode. So now I'm going to hit, well, I'll go to the home screen. And I'll say 200 divided by the tangent of 2.5. And again, that's degrees. And so x is 4,580 feet, right? So a little less than a mile away. A little trigonometry helped me do that.